Okay, let's go through attendance real quick. See who's here. Okay, Pedro? Pedro here. Omar?
Here.
Wu Chun?
Here.
Okay, Gregorio? Jordan?
Here.
Ann?
Here.
Ann?
I'm here.
I'm with Ann. Okay, Erica?
Here.
Ann is here. Okay. Thank you. Okay, Hong? Hong Tran? Okay, Long?
I'm here.
Ashley?
Here.
Assam? Assam? Husam? Okay, Manuel?
Here.
Raphael? Michelle?
Here.
Juan?
Here.
Eric?
Here.
Stephen?
Here.
Okay. Hung?
Here.
Kai?
Here.
Vin?
Here.
Jennifer?
Here.
Fernanda? Matthew?
Here.
Angie?
Here.
Armando?
Here.
Calixto?
Here.
Ismeen?
Eastman here.
Ismin? Ismin? Anis?
Here.
Okay, Eduardo?
Here.
Knock?
Here.
Sang?
Here.
Saccharin? Jose?
I'm here, but I'm gonna have to step out early.
Okay, Pedro? No Pedro? Gregorio? No Gregorio? Hong Tran?
Here.
Hong Tran is here.
Yes.
Okay, Hussam? Raphael? Fernanda? Saccharin? Okay, so we have our first exam is on Wednesday. We'll go over the exam review today. Okay, so make sure that you have Proctorio installed on your browser. As you can see, I have the Proctorio extension. This is going to monitor you during the exam. What you're going to do is you're going to log in on Wednesday at 3:40. You're going to log in here. Okay, and then it's going to run Proctorio. Why does it say time limit 60 minutes? That doesn't make sense. It should be 120. Don't want that. Okay. It's due 5:45. Yeah, 5:45. Edit. time limit. It's 125. I don't know why this thing didn't save. Save. There we go. That's better. Okay. So it's gonna have you. This is gonna monitor you while you take your exam. Okay, and you're gonna have to use Chrome. Make sure you have the Proctorial extension, okay, enabled in your. Okay, just go to extensions, settings here, and then go to extensions. Not settings. Sorry, it's more tools. It should be more tools. Where is it?
Hi, what should I do if my computer won't let me add it? It says it's like a safety issue.
What type of computer are you running?
A MacBook.
MacBook?
And I'm on Chrome.
You're on Chrome. And I won't allow you, if you go to more tools and extensions, it won't allow you to add the extension?
Yeah, well, I was on the, I went from Canvas and then clicked on like install the extension. And then it just has a pop-up that says like this app can eject or like take over your data or something like that.
I mean, you want to enable that, allow it.
Okay, I mean, I can check in settings and see if it'll work now, but I don't know what to do.
And it should, where's my home here? Yeah, you can enable this through, it's not coming up for me because I haven't, let me see if I can go to student view. It's not gonna enable, oh, here we go. No, still not gonna show it for me because of my view. But if you hit that, it'll prompt you to download the extension. Okay.
Okay, I'll try again and I'll see if it works.
Yeah, that would be good. So, yeah, you may have to just allow pop-ups, like sometimes it has an issue because it's not allowing pop-ups or something like that. You have a pop-up blocker on or something. So you're in Chrome, yeah, that's fine. Leave the student view. Okay, so you're gonna go in there. Now you're not gonna find the exam here. Okay, this is just to monitor. This is the monitoring site, and this is where you're gonna upload. This is where you're gonna upload your work. Okay, you're gonna upload your work here. Okay, now where are you gonna find the exam? Well, you're gonna go to the syllabus or to assignments. Oh no, sorry. You're gonna go to WebAssign. Okay, so that's gonna start the clock on Wednesday. You're gonna go to WebAssign, and then it's gonna say, oh, you wanna take the chapter 12-13 exam? Sure. Okay, so right here, take chapter 12-13 exam. Boom, yes. Okay, I wanna take these 10 questions. Okay, so there's only 10 questions. Okay, and so you're gonna go through and it runs just like a homework assignment, except for the fact that you're sending me your work through Canvas. Okay, through this is where it monitors you. Okay, so that I can see what you're looking at. Okay, on your screen and through a webcam. Okay, so I can see what you're looking at, and this is going to monitor you for that 2 hours, and then once the clock starts running, I think it even says, go to WebAssign. Let me preview this real quick.
I have questions.
So it says, yeah, question 1. Log into WebAssign and complete the assignment labeled Chapter 12 and 13 exam. Work out all your responses and submit your correct responses to each question on WebAssign. Upload a single PDF file of all your original work in sequential order for all of the exam questions here. Okay, so half the points come from getting the correct answer, the work, and half your points come from getting the correct solution, just the answer. What was your question?
So I have to do the work on WebAssign, and how do I download it from that to upload to?
Work on WebAssign. You just put your answers in the web. Let me go to a homework assignment, right? Let's say that you're in 12.5, right? So preview assignment. I don't want to preview the exam, right? So you're just going to go here, right? So let's say that this is this. You're going to plug in your correct answer here, blah, 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 right? The work that you're doing for this is going to be on a piece of paper, and that's going to be sent to me via PDF. Okay, you can scan it. You can use Cam Scanner. You can use the notes in your phone to create a PDF. You can create a Google Doc and save that as a PDF, however you want to do it. You just upload that file showing me your original work. Does that make sense?
So I have to screenshot the work on the screen.
No, you don't screenshot the work on the screen.
By the app, right? No.
Write the work. Okay, and you can take a picture with your phone and then put all those JPEGs in. Again, you can scan the piece of paper. You're gonna handwrite out all your work. Handwrite. See this? Handwritten work. Boom. There you go. I put this in my little scanner, or I use Cam Scanner, or I take a picture with my phone and then upload it to Notes and create a PDF. If I have an iPhone, if I have an Android, there's other apps that will do that for you. And if this was question number 1, this is all my work to question number 1. Boom, there you go. And then I do question 2, 3, 4, 5, 6, 7, 8, 9, 10. I create it as one PDF and I upload it at the end of the exam.
But where do I upload it to? The exam.
Where do you upload it to? You upload it here. It says log into WebAssign.
Okay, yeah, I got it.
There's only one question in the exam. Log into WebAssign, work out all your responses, and submit your correct responses. Upload a single PDF file of all your original work in sequential order for all the exam questions here. Okay? Does this make sense? Any other questions?
I have a question for WebAssign. I know sometimes the notation, I've had some issues with putting on the answer. Is there any leeway at all if it's very, very close, but it was just slightly off due to certain notation?
Yeah. Say it again.
So like if we're very close to getting the correct answer on WebAssign, but we accidentally punched it in kind of wrong, like notation wise, is there any leeway with that, or is it just completely wrong?
Okay, so half the points come from you doing the correct work, and half the points come from doing the correct answer. So if it tells you, like one person in the homework, they got an answer because they put a decimal instead of putting an answer with a square root symbol. Well, if you're supposed to put, if it says give me the exact answer, and you put a decimal approximation, then yeah, you're gonna get half credit for that problem.
Okay, thank you.
I think he means like in the homework assignment when it's asking us like for the answer, and then we have to put like I, J, K. Sometimes we put like the regular I, J, K, even though it's supposed to be like a vector. Sometimes we get it wrong that way, even though it's the same thing.
Okay,
That's
well,
what you mean.
come out of the same test bank as the homework questions. And so if you've been doing the homework, then you should know where you're getting your errors, correct? I mean, you should know, oh, I've got to use a vector here for I, J, and K instead of a value. Again, half the points will come off of did you do the work correctly, and half of them are going to be did you input it correctly. There's only 10 questions here. Okay, and I've used this same structure for last semester. I teach 280 every semester. So again, the structure of the exam is such that you just put in usually it's an exact value. You know, whether it's the vector or it's the you know, whatever you're calculating, whether it's the equation of a sphere or whatever it is, the values aren't too out in left field. They're usually like integers. If that makes sense. So I don't think you're gonna, there is a lot of room for those type of errors in this exam. Okay.
What are we allowed to have when we take the exam?
You can have anything you want except for your phone, basically, to be texting anybody.
So I could have my notes?
You can have your notes and your book.
Okay, cool.
Yeah.
I'm a little confused. So when I'm doing the exam on the WebAssign, and I did it on my paper and stuff, and I uploaded online. So I uploaded straight from Canvas, right?
Yes.
But I'm logging in Canvas from my laptop, and when I upload the thing, should it let me use another device to upload the work?
Yeah, it should. You upload the work. Why can't you just email the work to yourself and upload it there?
Because when I'm using Proctorio, it didn't allow me to use another app, right? Except for the one on.
I mean, we can look at it right now. I don't know if I've completely locked down your browser.
Because when I do Proctorio on my exam on other class,
okay,
doesn't allow me to use another app, another like tab. Yeah.
Right.
So,
yeah. No, exactly. Well, let's see what's going on here. Okay. So let's go back to the quizzes. Okay, I'll show you exactly what I'm looking at. Yeah, I get it. I get what you're asking. Okay, so let's go to edit. Let's go to Proctorio settings. That's what you're interested in, right? Okay, what's it going to record? It's going to record your video, audio, record your screen, and record the web traffic. It's just going to record your web traffic. I'm not locking down your browser. It's recording all the places that you went to. Okay, lockdown options. I'm not forcing I'm not forcing you to have one screen. I'm not forcing you to only be on one screen. I'm not disabling new tabs either. Okay, I'm not asking you to clear your cache. Okay, I am asking you to verify your video. I'm asking you to give me an auto ID check. That's going to ask you to verify using your driver's license or Santa Ana College ID. Okay, behavior settings. I have custom behavior settings here. Okay, navigating away, keystrokes, browser resize. This is just flags. These are flags. Leaving the room. If there's multi-faces in your room, it's going to flag it as well. Multi-face exam collusion. Okay, I don't have exam or end times or start times there. That's in Canvas already. Head and eye movements. I don't do head and eye movements because on math exams, everybody looks down. So if I flagged head and eye movements, I would get 700 flags. Okay, so I'm not locking your browser down. Okay, that makes sense. Yes, no, we good? Again, the people last semester, they caught on. And I also taught Calc 2 in summer, and we used the exact same thing too in Calc 2. So again, I think once you take the exam on Wednesday, you're going to see, oh, okay, this is pretty straightforward. Okay, if you need to use symbols, whatever, just use the calc pad. Okay, vectors, use IJK in the calc pad. Okay, here's vector notation. Boom, done right there. Boom, boom. Okay, so yeah. Any other questions about the logistics of the exam? How the exam is going to run? Does that answer your question, Hong?
Yeah.
Okay, good. Good. So again, it's going to run just like a homework, like the homework, but at the very end, at the very beginning, you're going to log into exam 1. Then you're going to do the homework assignment that's called exam, chapter 12 and 13 exam. And then at the very end, you're going to upload your work. Okay, upload your work. Okay, any other questions?
Yeah, I have a question. So will we have 5 different tries for each question too, or?
No, I think there's 2 tries. Let me see. No, there's not 5. There's.
So will it tell you right away if you get it wrong or not?
What does it do in the homework?
Yeah, it tells you. Yeah.
Does it tell you the right answer?
No. It said that you're wrong. Then
Again, it's going to run the exact same way. Let's see what the settings are on the homework or on the exam. Future. Okay, this is in the future. View, edit. Okay, view settings. Let's view the settings. Submissions allowed 2. So 2. You have 2 shots at this. 2 chances. Okay, questions, submitting answers, question parts. Yes, it's fine. Okay, scoring answers, use student's latest score. Show my work, no. Okay, it says, correct, incorrect marks after 1 submission, yes. Students' previous responses is shown. Okay, scores on assignment, question parts, okay. Answer key, no. The only time you're gonna get the answer is after the due date. Okay, the solution, the steps to solve the problem, that's also after the due date. Okay, hints, tutorials, after due date. Okay, but yes, you'll know whether or not you got it right or wrong after the first submission. So hopefully that helps. Okay, you're like, oh, I must have inputted the wrong syntax. Therefore, I'm going to try one more time. Right? Yes, you have to install the application in order to use Proctorio. Yes. It's up here. Boom, Proctorio. Boom. Okay, and it needs to be in Chrome. Okay. Oh, the other thing is you have to have a Wi-Fi that's not a mobile hotspot. You cannot use a mobile hotspot for Proctorio. So keep that in mind. Okay, like through a cell phone, because it's got to be able to track your IP address. Okay, so hopefully you guys have maybe used Proctorio in the past. I don't know, but if you haven't, just keep that in mind. Okay, again, they're pretty straightforward, okay? You'll have 2 hours. The total time it's suggesting that you have on this is 1 hour, so you have twice as much time than what's suggested. Okay.
I have a question.
Yes.
You said that there were apps that we can take a picture to upload it on the PDF file. What apps are those?
Okay, so do you have an iPhone or an Android?
iPhone.
You have an iPhone, so you already actually have an app installed there that will do this for you.
Oh,
It's called Notes.
okay.
So if you go to Notes, right? So if I go to Notes here, okay, and I go to the little camera, it says Scan Documents. You see that?
Yes.
You hit Scan Documents, and it says Scan it, and it will scan your documents for you, and it'll turn it into a PDF.
Oh, okay. Thank you.
You're welcome.
Hello, Professor.
Yeah.
Can I ask, like, I use the scanner to scan the paper. Like, is that okay? Like, if I move out the screen to scan it?
Oh, yeah, as long as you're finished with the exam at that time, that's fine.
Oh, okay.
As long as it's at the end of the exam and you're done with all your work, then that's fine.
Okay.
Yeah, not a problem. Any other logistic questions?
Another question. So our view in our camera, should it like be a certain way, or is like your view okay?
You mean the way that I have it set up at my house?
Yeah, like do you want to see like our full desk or?
No. Y'all, all you have to do is see your face.
Okay.
Because,
Thank you.
because it's going to record what your desktop is.
Okay.
So it may also ask you to show your phone and then put it away.
Okay.
Again, I've used this on multiple semesters already. It seems to work really well. You know, and I don't get any cheating. I would hope not at this level either. So people tend to be able to follow the rules. You know, up to this point, no Discord, no Instagram, no nothing. So. I mean, when it really comes down to it, it's your own personal integrity. So. Okay, I'm gonna stop sharing. Okay, so at this point, I wanna start going over any of the exam review questions that you'd like to cover. Okay, so are there specific questions on the exam review that you'd like to go?
Could we go over for the chapter 12 review, number 7, about the length of the median for the triangle?
Okay, sounds good.
Thank you.
Absolutely. Okay. Let me share my screen here. Come on, dude. I'm using computer audio. I do not want to use computer audio. Here we go. Okay, hope you can see my screen at this point. Come on, what's going on here? Ah, whatever. What the heck? Okay, sorry about that. Okay, number 7. This is chapter 12, number 7. Okay, so what does this say? This says, okay, find this. Oh, that's chapter 13. Let's go back to chapter 12. Okay. It says find the length of the median of a side AB of a triangle with these vertices. Okay, so the median, the middle there. Okay, with those sides. Okay, so distance formula basically. Okay, so we have this. We have 3 points in space basically that are going to create this triangle. Okay, which is going to create a plane. Okay, and we want to find, so we'll call this A, B, oops, call this A, B, and C. And we want to find the median of AB. Right? We find the median of AB. Okay. So find the length of the median of AB of a triangle with these vertices. Okay. So we want to find the length of the median. Okay, well, the first thing we need to do is find out, well, what's the median? Okay, well, the median here, well, let's look at A. A is equal to -4, 8, -5. Okay, and B is equal to -2, no, no, that's right. -2, -8, -3, right? -2, -8, -3. Okay, so we want to find the median of that first, and then we want to find the length from the median to point C. We'll find the length. What's the length there? Okay, so we're just gonna, to find the median, we just add the components up and divide by 2. Okay, so if we add these two up, -2 plus -4 divided by 2, that's just -6, that's -3. That's the middle value there. So I'm going to call this M, the middle value. Okay, add 8 and -8, we get 0. Oops. We get 0. And then add -5 and -3, that's -8 divided by 2, that's -4. Okay, so now we just find the distance to C. Well, what was point C? C was 12, -6, and 8. And then I want to use the distance formula for this. So I just plug these in. x2 minus x1 squared, y2 minus y1 squared, x2 minus x1 squared. Okay. And you get 9 radical 5 when you plug all that in. Okay, does it make sense?
Yeah, thank you.
Okay, others that you'd like to see done from the review here?
could we go over still chapter 12, number 12? It's the problem about the volume and using the triple scalar product.
Yeah, absolutely. Okay. So. Okay, so we want to find the volume of the parallelepiped, right? Oops. Okay, with edges of these here, P, Q, R, and S. Okay, so notice that P is the central point. So P is the central point in this. Point P. Okay, so there's my parallelepiped. Okay. And so we've got PQ, PR, and PS, right? PQ, PR, Q. I'll do S over here. And I'll do Q, I'll do R here. Okay. So the volume, according to the formula, the volume is equal to PR dotted with PS crossed with PQ. Okay. Actually, I'll do that backwards. Let's do PQ cross with PS. Okay, so we get this, and then we get that to be orthogonal. Okay, so, and then we're going to dot that with PR, and that'll give us our volume there. Okay, so what's PR? Okay, well, if we looked at these values, all we're going to do is subtract to get these values, right? So if we said, oh, well, what's PQ? Well, I would just subtract the difference between the Q components and the P components. So this would be 6 minus 4, 7 minus 5, and 6 minus 6. So that would be 220, right? So PQ would be 220 there. Okay, that would be our vector.
Oh, never mind. Sorry, the screen glitched, but I think it's fine now.
Okay, you're good?
Yeah, I'm good. Sorry.
All right. Sounds good. Okay. Well, for those of you that haven't tried this one yet, okay, so then you just go IJK, and then again PR is equal to 201. PQ is equal to 220, and PS is going to be equal to 700. Or sorry, 200. Not 7, 200. Okay, so if you do PQ dot cross PS, okay, you get 220200. Okay, but a bunch of things are going to cancel out except for this K term. K is the only thing that's going to survive. Okay, so you're going to get 2K. Okay, so that's with the cross product, and then you're going to dot that with PR. Well, PR is 2. We'll say that this is 002, and dot that with 201, right? So that's going to give me 002. Okay. Actually, it's not. It's if this is going to be negative 4. Sorry. Because it's 2, yeah, negative 4. So then this is 1. So this is negative 4. So so the volume, though, has to be a positive result because it's the absolute value of that. And so it's 4. Okay. Okay, so that's how you do that one. Okay, others that you'd like to go over?
It's number 15 on chapter 12.
Okay, number 15. Okay, so number 15 says find the point of intersection of these, right? Of these lines, right? We have line 1 and line 2. We want to find the point of intersection. We want to know for what value of x, y, and z are they all going to be equal? Well, just set them equal to each other. Just set the components equal to each other and solve for x, y, and z. That's just an algebra problem, really. Okay, so this is going to be, right, set this guy equal to this guy equal to this guy, and then set this guy equal to that guy, and you solve. Okay, do you need me to do the algebra?
No, that's okay.
Okay, next.
Could we go over 13 or number 13 from chapter 12? I was just, if you could just explain how to, like, since it's the line through that point and perpendicular to the plane. So could you just explain, I guess, the conceptual part about it being perpendicular to the plane?
Yeah, sure. So number 13, find the equation of the line through this and perpendicular to this plane, right? So it's going to go through this point and it's going to be perpendicular to that plane. Okay, so here's the idea, okay, is that we're going to use the definition of a plane, right? How do we get a plane? Well, a plane is the vector that's orthogonal to that plane are the coefficients. Does that make sense? So the normal vector to the plane, and the normal vector to the plane gives me, well, let's look at the definition of plane real quick. Okay, so definition plane, right, is we've got A, x minus x1, B, x minus or y minus y1, C, z minus z1 is equal to 0. Okay, so that's the definition of plane. Does that make sense?
Yeah, that does.
Where A, B, and C are a vector orthogonal, this is my normal vector to the plane. So if we have a plane here, we're going to have some vector that's orthogonal to that, right? And that's going to be my ABC. ABC, that's my vector. Now what I'm going to do is I'm going to take this tail of that vector and I'm going to move it over. I'm going to move that vector over to a certain point on the plane. And that point on the plane is 6, negative 6, 6. Okay? So I'm taking the normal vector, I'm just putting it through this point. Does that make sense? Does that help?
Yeah, that helps.
Okay. And so what is A, B, and C in this case? Well, A, B, and C is, the normal vector is negative 1, 2, and 5. Okay. And so what's the equation of this line? Right? Well now we know what the vector is, right? This vector is, we're going to call vector V, right, in our line, right? Well, because for this line it goes through a point P naught, right, of 6, negative 6, 6, and it has vector V of negative 1, 2, and 5. right? Because it's asking for the line, right? Find the equation of the line through this and perpendicular to this plane. Well, the normal vector is always perpendicular to that plane. That's how we get the equation of a plane. And so they're kind of just setting you up here to say, oh, well, this is going to be, okay, x is equal to x naught plus at, y is equal to y naught plus bt, and this is a vector, by the way, and z is equal to z naught plus zt, or plus, this is b ct, and so you're just like, oh, well, this is just going to be 6 minus t, right? Because a was -1, and then y is equal to -6 plus 2t, and then z is equal to 5 plus, no, it's not 5, 6 plus 5t, right? So there's your x, y, z. Okay, for your line, this is now a line. Okay. This was 13, by the way, right?
Yeah, I think it was 13. That makes a lot of sense, so thank you.
Okay, others? Again, I don't have time to go over all of them, but I will go over the ones that you want me to go over.
So remember 11 from chapter 12? I mean, I got it correct, but I'm not sure if I understand the concept still, because why do you, like for the, I guess the little bar thing, if that makes sense, like it has like a little ledge.
Well, let's look at it.
Why would you cut through from like the point between the blue and the red? Why would you cut through from there to P? Because I did that and got it correct, but I mean, could you just maybe go through the process?
Okay, so we are basically pulling. So you got to kind of think of like a physicist, right? Okay, so they're saying that A here is 2, B is 2, right? And then like what actually is turning? What actually is turning here? Well, it really is turning on this kind of imaginary shaft here. It's rotating on this imaginary shaft. Does that make sense?
Yeah.
Like the sum of those there is the same as putting a bar connecting the two. Are you okay with that? If I'm pushing this, isn't it still just going to rotate around that? Right? Does that make sense?
Yeah, it does.
Okay. So what's the angle of rotation? The angle of rotation is this guy here. They're saying that this is 30 degrees, but if this is a 2 by 2 square, if that's a 2 by 2 square, then isn't this angle 45 degrees? And isn't the fulcrum here, this is the fulcrum, okay? This is really just a lever, okay? I don't know if you know anything about levers and fulcrums, but on a teeter-totter or a seesaw, however you want to call it, okay, your fulcrum is in the middle. When you're doing torque, your fulcrum is on the end. Does that make sense?
Yeah, it does.
And so here's your fulcrum and here's your lever, right? Here's your fulcrum. Okay, here's your fulcrum and there's your lever. So the length of your lever is 2 radical 2. Why? Because this is a 90, 90, 45, 45 triangle. Okay, so how many, and D is 37 pounds of pressure. It's 37 pounds of pressure. So my torque is equal to my force times my distance, or work. It's work. Is it work or when we're looking for torque? That's right. It's force times distance, or the length of my lever. Okay. Yeah, force times distance times the sine of theta. Okay, and that's the angle that my force makes with my lever. Okay, and again, this is being pulled and not pushed. So it makes a difference. And the sine of theta. Well, what's the force? The force is 37. What's the lever? The lever is 2 radical 2. And what's the angle? The angle is the 45 plus the 30, which is 75. And that should all come out to be 101.09 foot-pounds. Okay. Because you're thinking like, I forget the word, but like, what is the sum of those two, of that whole blue thing? Well, how is that acting, right? It's acting along this imaginary axis of length 2 radical 2. Okay, others that you'd like to see done? Any from chapter 13 that have stumped you, guys? I mean, or chapter 12. I mean, we don't have to be done with chapter 12.
Could we go over question number 2 for chapter 13?
Question number 2. Sure. Wait. Do you want to save changes? No, definitely not. Okay. Question number 2 on chapter 13. Okay. It says, find the equation of the normal plane, okay, to this to this space curve at 2, 4, and 8. Okay, so equation of the normal plane. Okay, so yeah, this one's kind of interesting. Okay, the equation of the normal plane. What's the normal plane? Well, yeah, it's going to be orthogonal to this guy, right? Okay, so what's the tangent of this thing, right? So maybe a picture is going to be worth 1,000 words here. So it's going to be like, well, how are we going to do this? Okay, so okay, because on a lot of these they give you the necessary information. It's just you got to figure out, well, what exactly are they talking about? Okay, so we have R of t is equal to t squared and t cubed, right? T squared, yeah. At the point 2, 4, 8. We want the equation of the normal plane. Okay, so this one's kind of tricky because you're thinking, what's normal to a normal plane? Why would I want to think what's normal to the normal? What's normal to the normal? That doesn't even sound good. But that's really what you have to think about. What's normal to the normal? Why? Because I need a vector v that is normal to the normal plane. You're like, that's interesting. Let's look at this. Let's look at a space curve, okay? X, Y, Z here. Oops. X, Y, Z. We've got this space curve, curved up, whatever. And at some point, at point 2, 4, 8, right? 2, 4, 8, we have, okay, we have a tangent to this, right? We have a tangent to this, but and normal to the tangent is the normal line. Does that make sense?
Yeah.
This is normal to the tangent, right? So, but this is the plane that I'm interested in. This is the normal plane, right? Wouldn't the normal line be part of the normal plane? And so wouldn't the vector that's normal to that normal plane be the original tangent? Does that make sense?
Yeah, I think the diagram really helps.
Oh yeah, I'm sure. Hey, it's you got to the thing in Calc 3 is you really got to start visualizing these things in your mind, right? You're like, where is everything located, and how do I figure out, you know, where everything goes? Because it's pretty tricky. Okay, and so all you do is take the derivative, which is going to be your v, and plug in when t is 2, right? So this is going to be, what's your v? My v is equal to 1, 2t, and 3t squared, right? So v evaluated when t is 2 is going to be 1, 4, and 12. Okay, and so we're just going to use the equation of the line, or plane, sorry, equation of the plane. So this is going to be a times x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0. And all you're going to do is plug in your 1, your 4, and your 12, and then your 2, your 4, and your 8, and then just solve. And when you do that, you get x minus 2 plus 4 times y minus 4 plus 12 times z minus 8 is equal to 0, and you can just solve this pretty easily. This is x plus 4y plus 12z minus 144 is equal to 0. And if you want to toss the 144 over, you can. It's not necessary. So x plus 4y plus 12z equals 144. So either of these would be fine. Okay, others that you'd like to see? Done?
From chapter 13, could we go over number 5?
Yeah. Let's do that. Okay, so we have what, a circle and something, and or a cylinder? What's going on? Number 5 here. Okay, yeah, the cylinder. Okay, and the plane. So we want to find the curve of the vector describing the curve of intersection of these two, right? So again, picture is worth 1,000 words. We have a cylinder and we have a plane basically that are, right? So we have this cylinder, x squared plus y squared equals 25, and then this plane, x plus y plus 6z equals 7, and they're intersecting. We want to describe the curve, okay? The space curve that describes that intersection. Okay, so what I'm going to do is I'm going to parameterize x and y. I'm going to say that x is equal to 5 cosine t and y is equal to 5 sine t. I'm going to solve this guy for z. Okay, z in terms of x and y. Okay, so solve for z, because that's going to be my f of x, y. Okay, I don't have a z for the cylinder. Z can be anything you want it to be. But I'm going to solve for z in my, so when I do that, z is equal to 7 minus x minus y over, okay. So this becomes 7, 6 minus x over 6 minus y over 6. That's my f of x, y. Okay. But, okay, we want to change this into a function of t, right? We want it to be r of t. So this is r of t. This is my vector valued function in respect to t now. So I'm just going to replace x and y with my parameters. And that gives me r of t. Okay. And so actually it's not r of t yet because it's not a vector. This is just a function. This is just f of x, y. And now this is f of t, right? F of t. Okay, so this is f of t. It's not r of t yet, it's f of t. Okay. Okay, that's good. That's good, because we need it to be a vector though. Okay. So we need to be a vector r of t in terms of what? In terms of xi, okay, plus yj plus zk, right? Except this is this going to be in oh, it's 3 dimensions? Is it? Can we get rid of that second dimension though? I'm thinking. Thinking z in terms of, no, it's fine. Okay. Okay, and so we get, okay, because we want this to be a vector value function and not just yeah. So let me go back to z here. This is let's keep z. Z equals this, z equals that. Okay, so this is z of t. This is x of t, I, y of tj, plus z of tk, right? So what is x of t? Well, we already knew that. That's 5 cosine t, I. What's y of t? 5 sine of tj. And what's z of t? Well, z of t is this whole thing. This is 1/6 times 7 minus 5 cosine t minus sine minus 5 sine tk. I think that's it. I think we're good. Is that good? Okay. Because I mean we do need a z component. Yeah. IJK. This was 5? Yeah. So IJK, yeah. Yeah. Okay, they just put it in component form. They leave it in component form. Okay, so hopefully that makes sense. Okay, others that you'd like to see done?
Can you go over number 4?
4 on
yes, on 13.
Okay, find the limit of this thing as t goes to infinity. Okay, well, I think we're just taking limits, right? So what's this? This is 1 over e to the 4t. This is 1 over t, and this is 7t squared over t squared plus 1, which you could use L'Hopital's rule on that if you really wanted to. You could do 14t over 2t, and then use L'Hopital's rule one more time, you get 7. Okay, so this, as t goes to infinity, why can you use L'Hopital's rule? Because it's going to be infinity over infinity, right? Infinity, it's an indeterminate form. Okay, infinity over infinity. Okay, but what happens when you do 1 over infinity? Well, that goes to 0. And what's 1 over infinity again? Well, that goes to 0. And so this thing goes to 7 when, you know, the limit as t goes to infinity. As t goes to infinity, this thing goes to 7. Okay, so you get 0, 0, 7. Okay. Okay, others?
Professor, on number 10, the sketching was a little difficult.
Okay. Number 10?
Yeah.
Okay. On chapter 13? Okay. So it says on part B, is that what you're looking at?
Yeah, part B.
So find R and R1, sketch the curve. Okay, so yeah, let's look at this real quick. Okay, 10. Well, what was R1? Negative 1. That was 7i minus 4j. Is that right? So 7, 4. And R prime of negative 1, this is going to be negative 14i plus 12j. Is that right? This is negative 14, 12. Okay. We have R of t is equal to 7t squared I. I'll write it like this. 7t squared I and then 4t cubed j, right? Okay. So yeah, this is kind of interesting. What is this? This is x, right?
Professor, isn't it negative 4?
Oh, is it negative 4? For which one? Oh, for this? Yeah, negative 4. Thank you. Okay. Yeah. Okay, so this is x, this is y, right? Okay, so so x equals, we want to look at kind of what's happening with the, does it say sketch the curve or does it say sketch the vectors? Number 10, oh, sketch the curve defined by R and the vectors on the same set of x's. Okay, so what I'm going to do is I'm going to kind of cheat. We only have two dimensions here. We have the x dimension and the y dimension. I'm going to say x is equal to 7t squared. Okay. And so I'm going to solve this for t. T is equal to x over 7 square root, right? Plus or minus. Okay. And so I know y is equal to 4t cubed. And so y is equal to 4 times this guy, right? Plus or minus x over 7, okay, to the third power. Okay, so okay, x is always positive, that's fine. So y equals plus or minus, okay, 4 times x over 7 to the 3/2 power, right? Okay, so this is going to be plus or minus 4 over 7, radical 7, times x radical x is equal to y. Okay, so the idea here is, well, what happens at 0? What happens when x is 0? What's y? Isn't y 0? So we would start at the origin, right? Okay, and what would that make t? T would be 0, right? So you want to think about this, right? Like, okay, so we're going to start when t is 0. We're going to start there. Okay. So what about when t is 1? Where are we at when t is 1? We're at 7, 4, right? When t is 1. Okay. But where are we at on our X and Y's? I don't know. Do I want to do in terms of X and Y's? I mean, in terms of X and Y's will give me kind of an idea of what this thing looks like. I didn't really need it to do the problem, but notice that there's what can X not be? Well, Y can be anything I want it to be, but X can only be positive numbers. So there is a domain issue there. Let's go, let's see what this is going to look like. Okay, so Y equals, okay, what did we have? We had 7 over 4 over 7 over 7, 4 over 7 times the square root of 7. Okay. Times x times radical x. Okay. Okay, and so we have that one, but we also have this one here. Well, we negate this thing. So let me copy and paste it. Oh my gosh, this is. I just want to take into account that this thing could be negative. Okay, and so we have this thing here. Okay. So which one is it that we're really looking at? Well, let's plug in some values here and do the original function and let's see what happens. Okay, so for some values of t. Okay, so this thing looks like it's doing this and it's doing this. Okay, so now let's go back to our original function here and let's start messing around with these things. Okay, so it's saying what happens at -1. That's kind of weird. Okay, so what would happen at if at t is equal to +1, where are we at? Well, we would be at 7, 4, right? Okay, but at -1, okay, we're at, let's see, let's at r of 1, we're at 7, 4. At r of 2, where are we at? At r of 2, where are we at? We're at -2. Let's stick to the negatives here. R of 2, where would we be at? We would be at, so we'd be at 1, 2, 3, 4, 6, 7, 1, 2, 3, 4. We would be here, right? This is at t is equal to 1. Okay, t is equal to 2, where are we at? Well, we'd be way up here somewhere. That's t is equal to 2. Okay, so where are we at with t equals -1? For r of -1, it's just 7, -4. Oh, okay, so we're still out 7, 1, 2, 3, 4, 5, 6, 7, but now we're down -4. So this is -1. T is equal to -1, okay. So when t is equal to -1, we're here at 7, 7, 4, okay. Okay. That's when, that's where we're at. Okay, however, we want to know what's happening at r prime of -1, which is the tangential vector. Okay, what's happening at r prime of -1? Well, at this point here, what are we doing? I'm going to get rid of some of this stuff. Okay, the positives really. Okay, this would be at r of -2. We'd be down there. Okay, but what's happening at 7, -4 is we want the tangential vector, which we said was -14i plus 12j. So this is -14i 12j, which means that from here, we would go over 14 in the x direction. Okay, so so this would pass through 7, and then we'd have to pass through 7 more, right? So that's x, and then we go up 12, right? Up 12 in the j direction. So we'd be, instead of down 4, we'd end up 8, right? Up 8, and that's our head is there. Okay, so we're really ending up with our head at -7, 8, right? So our head is there, and where's our tail? Our tail is at the point 7, -4, because that's where we're tangent to at that point. And so that's our tangential vector, okay, along this curve. So we drew the curve. I'm screwing it all up here. Okay, we drew this curve. This is the curve in the negative direction, by the way. This curve is in the negative direction. This is as t is less than 0. This curve is in the positive direction. This is as t is greater than 0. Okay, but we're interested in what happens in the negative region, because we want to be tangential, right, at that point. And so r of -1, this gives us our location, and then the tangential, this gives us our tangential vector. Okay, so this is the location vector of where to start our tangent vector. Okay, does that help?
Yeah, that helps a lot.
Sounds good. Okay. Others?
For chapter 13, number 3, it says, I mean, I'm looking at the answer key right now, which I got, but I just want to check for the orientation of the curve, if you could go over that. Thank you.
Yes, yeah, this one's kind of cool. Okay, in that we have 5 sine of t, right? Sine of t. Is this an I or a J? Let me see. For number 3, right? Yeah, 5 sine of t I plus cosine tj, right? So you're like, that doesn't look right. Why doesn't that look right? Because if you're thinking of like a unit circle, what should go first? Well, the x should go first with the cosine, and the y should go second with the sine. But that's kind of reversed here, right? So where's this one? Number 3? Yeah, let's do 3 here. Okay, so we have 5 sine of r of t is 5 sine of t I plus 6 cosine tj. You're like, okay, well, this is my x value, and this is my y value. Okay, so if I plug in some values, known values of t here, right? Let's find out what x and y are. Okay. So if t is 0, the sine of 0 is 0, so I just get 0 for x, the cosine becomes 6, right? 6. But that's kind of counterintuitive, because what does that mean? That means that we start when t is equal to 0, we're starting 6 up, not 6 over. We're starting 6 up. Oh, okay. And then what happens at pi over 2? This is 1, 2, 3, 4, 5, 6. What happens at pi over 2? Well, the sine goes to 1 and the cosine goes to 0. Oh, okay, so now we're going here, right? 1, 2, 3, 4, 5. So this if we continue the pattern, this is going to go 1, 2, 3, 4, 5, 6. This is when t is equal to 0. This is pi over 2. This is t is equal to pi over 2. And then this is equal to t when t is equal to pi. To 0, by the way. Right? And so what's the orientation of this thing? Well, this thing is an ellipse. 1, 2, 3, 4, 5. Right? That's an ellipse. But what's the orientation is it starts and it orients it clockwise instead of counterclockwise, is what we're used to. We're used to it being oriented counterclockwise. This thing is oriented clockwise. Does that make sense? Why is it oriented backwards? Because we flip the sines and cosines. The trigs are reversed. Does that help it, Yasmin?
Yeah, that makes a lot of sense. Thank you.
How do you pronounce your first name?
It's Eastman.
Eastman?
Yeah.
Okay, others? Okay, well, make sure that you are working through this stuff, okay? Yeah. And you know, you can always send me an email if you need. Matthew, you have a question?
Yeah, Professor Woody, are you gonna post this recording too?
Yes, absolutely.
I actually have one more question for chapter 13, number 4. I know we went over it. It was the limit problem. And I understand how it's how the final answer is the 0, 0, but then I don't understand how you get 7, because I'm trying to use it to solve it using L'Hopital's rule, but I'm not sure if I'm doing the right thing just for the z component.
Okay, so what was it? It was 14 something? I don't know. What was it?
The original equation?
Just the z component.
Oh, it was it was 7t squared over t squared plus 1.
Okay. So would you agree this is infinity over infinity?
Yeah.
Okay, so we can use L'Hopital's rule, right? So with this, we're going to take the derivative of this. So the derivative of the top is 14t over the derivative of the bottom, which is t squared, which is 2t, right? So that becomes the limit as x over infinity. And would you agree that this is infinity over infinity?
That would be 7, right?
No, this is still infinity over infinity.
Oh, okay.
You can't. Yeah, this is not 7. This is still infinity over infinity. Does that make sense?
Yeah.
Okay, so now we're going to do L'Hopital's rule one more time. This is 2.
Oh, and that's how you get the 7.
Yes. So this is 14 over 2 equals 7. You have to keep going until you don't get an indeterminate form.
Okay, yeah, I think I just I messed one of the steps up, but that makes sense. Thank you.
Sounds good. No, the study guide is not due. Only do it if you want to pass the exam. It's entirely up to you whether or not you want to work through it. Okay. If you don't want to pass the exam, you don't have to do it. But yeah, no, you're not gonna turn it in. It's just for your reference.
Could you help do number 4 on chapter 12?
Yeah. Help you. Yeah, help you set it up. What was number 4? It was. Oh yeah. Okay. So number 4. Okay, write an inequality that describes a region containing all points on the spheres of radius 9 and 5 centered at the origin. Okay. Okay. So just the sphere is x squared plus y squared plus z squared equals r, right? R squared. So we have a sphere of radius 5 and a sphere of radius 9, right? And so we want all the stuff between these spheres. So using inequality, this is just going to be big R squared and little r squared. So this is going to be 25 is in between this, is in between 81. Right? That's it. Done.
Thank you.
Any other?
Number 17.
Number
chapter 12. Yes.
Number 12 on what?
Number 17, chapter 12.
Number 13, chapter 12.
17.
Oh, 17. Yeah, 17.
Yeah, thank you.
We have x equals 4z, right? Is that the one you want? X equals 4z? Yeah. It says find the equation for the surface obtained by rotating the line x equals 4z. Okay. About the x-axis. Okay, so just draw your axis. Okay. Okay. So x equals 4z. Well, let me go to the other one here. Come on. Okay. So x equals 4z. Okay. So what is that going to look like in 3 space? So that's going to be on the xz plane, right? What's the xz plane here? It's this guy here. Okay, so that means for every 1 or every 4 I go up in, or I'm sorry, every 4 I go up out in x, I go up 1 in. Before I go out, I go up 1. So 0, 0 is a point on this, but it's also going to look like this. Okay, so we get this guy here, and we want to rotate it with respect to the x-axis. Oh, okay. I'll rotate this thing with respect to the x-axis. What do we get? Well, we get a cone oriented along the x-axis. So what's a cone oriented along the x-axis look like? Well, if you look at it, it's ax over x squared over a squared plus y squared over b squared plus z squared over c squared. That if you go back to the book, okay, and you look at all those different, equations of cones, that whatever it's oriented along whatever axis, that's what's in front here. This is oriented along the x-axis. That's the rotation. That's the axis of rotation. Okay. So, well, what do we know? We know that that x is equal to 4z. So let me square both sides here. So that would mean that this would be x squared over 1 is equal to y squared over b. Okay. Okay, so y squared, right, over b, y squared over b, okay, is plus z squared, right, z squared over c, okay, z squared over c, okay, is going to be 16. Okay, 16. So x squared plus y squared, okay, z squared. So this is x squared equals 16z squared, right? X squared equals 16z squared. So this would be x squared over 16 is equal to z squared. Okay. So in this case, what's a? A squared. What's a squared? What's the number below the x squared? Well, it would just be, this would be like 4 squared. Right, so x over 4, x squared over 4 squared is equal to z squared over 1 squared. Okay, so that's like what a and c are, right? That's what a and c are. Okay, if you let y be 0, if you let y be 0, okay, letting y equal 0. So along this axis, okay, when y is equal to 0, that the problem is that the y is not always 0. So we'll get to that in a second. Okay. What are the slices here of this thing? When y is 0, it looks like a straight line. Okay, when y is 0, the slice is a straight line. The traces of it are a straight line. Wish I had a good diagram of that. Think of a cone, right? Think of a cone here. Okay, in this perspective, and if we slice this right down the middle, what do the slices look like? Well, they look like triangles. Okay, they look like triangles. However, this is when y is equal to 0, we get this slice, this triangular slice. Triangle slice. However, if we don't let y equal 0, we go out, and we say, well let's let x vary, or let's let y and z vary and let x be 0. Okay, or well, 0 is not going to be good, because that if x is 0, then the whole thing goes to 0. But again, the idea here is letting y be 0. We can figure out what a and c are. Okay, y squared. Okay, y squared over b squared plus z squared over c squared. So I know what a and c are. If I let y be 0, okay, then a squared is 16, and z and c is 1. Okay, So what I need to figure out what B is. Okay, what is B here? Well, what would be nice is if I could let this thing here go to 1. Let's let x squared over 16 equal 1. Okay, because then I just get the equation of an ellipse, right? Does that make sense? So let x equal 4, because if I let x equal 4, then this thing goes to 1. This whole thing goes to 1. And I'm just left with 1 is equal to y squared over b squared plus z squared over 1. Okay. But this has got to be a circle. Why does this have to be a circle? Why does this slice have to be a circle? Well, it's got to be a circle because we're rotating it, right? We're rotating it. And if I go out 4, if I let x equal 4, remember, if we looked at the YZ plane, the XZ plane, look at the XZ plane, what was the equation? The equation was this has a slope of 1/4, right? Actually, we'll make it positive x this direction. This has a slope of 1/4, right? Means that every time I go out 4, I go up what? I go up 1. So what would be the radius of that circle? Wouldn't the radius be 1? Wouldn't the radius of that circle be 1 if I went out 4 in the x direction? Wouldn't that slice, this slice of this cone, have a radius of 1? Yeah. So we know that this has to be 1 equals y squared plus z squared. Okay, in what? In the YZ plane. In the YZ plane, right? So the YZ plane. Again, maybe we'll go back to my original drawing. It's this slice, but in the YZ plane, right? So YZ plane. Right? And it's in the YZ plane. Slice it. Slice it. I don't like that slice. It's what I have. I have been taking this piece of paper and I'm slicing the cone. And so what do I know? Well, this has radius 1. This is a circle of radius 1. If that's a circle of radius 1, then what is b squared? Well, b squared is equal to 1. Ah, okay. So this becomes x squared over 16 is equal to y squared over 1 plus z squared over 1. Oh, okay. And so this is x squared over 16 is equal to y squared plus z squared. You can leave it like that. Or you can do 16y squared plus 16z squared. Either of those two are acceptable. That's the equation of the cone that has that slope. That you know, the edges of the cone have the slope x equals 4z. If that makes sense. I mean, again, it really comes down to that drawing. You're taking those slices in those planes, right? Those traces. Okay, you take your slice in the XZ plane, it creates a line. You take your slice in the YZ plane, it creates a circle. You're just figuring out, well, okay, well, what's going to correspond to A, B, and C in the equation of the cone there. Okay. Any other questions? Any other last minute questions before?
I know we went over for chapter 12 the problem for the triple scalar product and the volume. Could you just show the diagram again, like the diagram of the volume you drew? Because I didn't get the like how it was labeled with each.
Oh, yeah. Okay, so like for the P, Q, and R.
Yeah, exactly.
Okay, so we said that that it's P, right? Okay, so, and you can do this a few different ways. It really doesn't matter how it's labeled in a sense, just the main idea. But generally what I like to do, okay, is I like to make sure that when I do my cross product, I'm getting something orthogonal. Does that make sense? So
I mean, I get it based off of the equation, but I'm just a little bit confused about like visualizing it.
yeah. So you can make any of them anything you want. So I mean, I guess if you really want to be accurate, you could find out where these points are in 3 space and then draw it out. But I usually will just orient my axes according to one of them. So I'm just going to say, you know, I don't know, you could do this QRS if you really wanted to. You just got to make sure that you know which one you're doing and if it makes sense. Okay, this means that I'm taking PQ into PR. I'm going to cross product PQ into P.
Oh, I can't see any. Like I can't see the screen, by the way.
I'm sorry. Yeah, let me screen share. My bad. Okay, so I just did. Okay, I just did PQ and PR. Does that make sense? Okay.
Yeah, it does.
This should be Q here. Okay, so it just means that I just need to know that in order to find the area of this base, I have to cross product. Okay, does that make sense? I have to cross product and I want it to be orthogonal. I want it to be in the direction of S, basically. Does that make sense? I want the cross product to be in the same direction. So I'm going to do my right-hand rule, right? The right-hand rule. Okay, so PQ is going to go into PR. It's going to cross into. Okay, and so, but we're going to take that and we're going to dot it, right? So this thing is, I just call this K for, well, not K. We'll come up with some other thing. I don't know, B for base. Let's call this B, right? So if I dot this B for base, okay, with S, that'll give me the volume, okay? So PS. Okay, so again, and then you just take the absolute value of that. Okay, so that's the main idea.
Okay, that makes a lot more sense. Thank you.
Okay, others? Okay, well, if there's no others, let's just call it a day. And again, if you have any other questions, let me know. Okay, otherwise.
Professor?
Yeah.
Quick confirmation. You said Proctorio won't be possible through hotspot?
Yeah, if you have a mobile hotspot, it generally doesn't work through a mobile hotspot. So if you, it's through a mobile phone. Like if you go to a Starbucks, it should work. Or if you're at a library, any other Wi-Fi connection. But if you create a mobile hotspot with your cell phone, it has a hard time with that because it has no designated IP address.
Thank you.
It needs to be at a physical location. You can't take it on the test on the beach. Okay.
Excuse me, Professor. Did you call attendant today?
I did actually.
Oh, I'm come late, so that I got only 80. Okay. My name Sakirin One.
Okay, let me bring it up here real quick.
Thank you, Professor.
Okay. And there's another person that came in late too, I think. Okay, so assignments. No. Attendance.